Hi everyone, in this video we're going to go over another Leetcode question, contiguous array. Major tech companies like Google, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given a binary array, find the maximum length of a contiguous subarray with equal number of zeros and ones. Example 1, 0, 1. Output is 2. 0, 1 is the longest contiguous subarray with equal number of zeros and ones. Example 2, 0, 1 and 0, 1. We have output is 2. 0, 1 or 1 is 0 is the longest contiguous subarray with equal number of zeros and ones. The length of the given binary array will not exceed 50,000. Excuse me. So let's try to understand what the question is telling us. This is a very famous question, so if you learn it now, that would be helpful in the future. So, given a binary array is an array. The elements of the array are either zeros or ones. For example, this is a binary array. There is no 2, 3, 4, etc. Only zeros and ones. Find the maximum length of a contiguous subarray. What is a contiguous subarray? A contiguous subarray is a subarray that has all the elements next to each other. A subarray that all the elements are next to each other. For example, this is a subarray. This is a subarray. Or this is a subarray. And we are looking for a contiguous subarray with equal number of zeros and ones. This is a contiguous subarray with equal number of zeros and ones. Or this is a contiguous subarray with equal number of zeros and ones. And we are looking for the maximum length. In this case, this is the maximum length. So that we will return 8 in this case. 1, 2, 3, 4, 5, 6, 7, 8. So this is what the question. This is the question. And we have two examples here. Example 1, 0 and 1. In this case, we return 2. 2 is the longest contiguous subarray with equal number of 0 and 1s. Example 2, we have two subarrays, either 0 and 1 or 1 or 0. And in this case, we return 2 as well. So, how can we solve this question? There is intuitively, we can say, we can create two for loops, one outer for loop and one inner for loop. Outer for loop stops at every index, and inner for loop goes through the rest of the array and tries to find the maximum array, then returns the length of the array. But that would be very time consuming. I mean, the time complexity would be O(n) squared, so that wouldn't be quite optimal. So we are looking for a more efficient way of solving this question. Let's get on the whiteboard and try to solve it. So instead, what we can use is we can create a hash map to store the data, and to find a subarray, what we need to do is we keep a counter. We keep a counter here. And every time we will see a 0, we will decrement the counter So in this case, -1. And every time we see 1, we will increment the counter. And when counter stops at 0, that means we have a contiguous subarray, and we return the length of the subarray, in this case 2. Because we say, for example, this is counter is 0 at -1 index, and 0 to -1. So in this case, 1 minus 1 is 2, is the length of the array. Let's see this example. Incremented the counter to 1. 0, decremented the counter to 0. Incremented the counter to 1 and 0. So we have one subarray here, we have 0 here, and one subarray here. The maximum length is 4 in this case. So we return 4 for this one. Excuse me. Let's see this example. This is a little different. In this example, we don't see any zeros. But we don't have to see zeros only. We can see same number again, same counter number. If we see same counter number again in the array while we iterating, that means we have a subarray between those numbers. For example, let's start. 0 counter is -1. 0 counter is -2. 1 counter is -1. So we have a subarray here. Between this -1 and this -1, we have a subarray. And 0 counter is -2. 0 counter is -3. 0 counter is -4. And sorry, we have another one between -2 and -2. So that is this one, or this one. So -3 and -3, we have another one here, this one. And -2 and -2, we have another one here. But the longest subarray here is this one, between this -2 and this -2. So what we can do is, if we store this counter here as we see this, for example, actually I can explain it on the algorithm better. First we create our hash map. We need to store the numbers. If we store these numbers in the hash map, we can check between these numbers. And every time we come across, then we can say this is the number. So we have a counter number and we have the maximum length. We keep the maximum length in a number and we keep the counter in a number as well, in an integer as well. So we go through the array. Every time we see a 0, we decrement it. Every time we see a 1, we increment it. Increment the counter. So this is what we do here. And every time we put the key and values into the hash map. So we put the counter and as the value its index number into the hash map. So first thing, we need to put 0 as the key and -1 as the value into the hash map. This is default hash map. I will explain why we do this in a minute. We start with this map put 0 and -1. Think about it like when we start doing linked lists, we start with the dummy variable that starts with -1. This is the same kind of logic, but we need to start with 0 and -1. I'll explain that in a minute. Every time we need to put the counter into our map. For example, here we see 0. Count is -1. So we check if it's in the map. If not, we put it in the map. And value is 0. Value is the index number of the item. This is what we do here. We check if map contains the key count. We check if this count is in the map. If not, we put in the map. That's what I do here. If it's not in the map, put in the map. And key is the count number, index number is the value. Again, counter is -2. Is it in the Is it in the map? No. So we put that one as well. -2, and -2 index is 1. So, okay. Now next iteration, we come to -1 again. Does map contain the counter -1? Yes, there is one -1. So what we do is, this time we don't put this in the map. We're not putting this in the map. That's why I put those numbers above and the other ones here. Only the ones in the maps are here and the other ones appear twice, so I put them above. This time I check maximum what I have so far. In this case, I start with 0. Let's put it here, 0. And index number minus the index number I stored here. So in this case, index number is 0, 1, 2 minus the index number I store here for -1 is 0. So that will give me 2. And I will compare with the previous maximum I have. I have maximum this, and I have new maximum here. So I will pick this. This will return 2, and I will increment my maximum number to 2. So what I do is, every time I see a number that exists in the map, I compare with the map. The linked is between these two numbers. If this linked is my global maximum, is greater than global maximum, then I will set this to global maximum. Otherwise, I'll keep the global maximum. So come to this. Again, is -2 in the map? Yes, it is. So what I'm going to do is I minus, I is in this as 0, 1, 2, 3, minus, get the count of the -2 value. So that will be 1. 0, 1, 2, 3 minus 1. That will give me 2. And maximum length does not change. It's still 2. And I continue. -3. Is it in the map? No. So let's put it in the map. -3 is here. And index number is 0, 1, 2, 3, 4. -4 is here? No. Let's put it in the map as well. -4. And value is 5. Okay, here we go again. We got another -3. And let's check in the map. Yes, we have -3 at index 4. So -3 at index 6 minus -3 at index 4, that will give me 2. And I will compare with the global maximum that I keep in the array. So this is the same, so I'm not updating this. This will again return 2, so maximum will be 2. Then finally, -2. Is -2 in the array? Yes, it is. In the map, yes. So what I do is, I is in this case 0, 1, 2, 3, 4, 5, 6, 7. 7 minus, the index value here is 1, 6. That will give me a new, so this will return 6. This part will return 6. So I will compare with my global maximum, which was 2, and that will return the new maximum. So new max will be 6. Okay. So this maximum will be 6. And so let's prove it. 1, 2, 3, 4, 5, 6. As you can see, I have length of 6 between -2 and -2. So this algorithm works. And finally, I will return this maximum number. So this is pretty much the logic. We put, I will summarize again. Actually, let's make this a little more simpler for you to understand. This part means if a of I equals 0, count C plus -1. Else count plus +1 plus 1. So, sorry. So this ternary operator is just a shorter way of writing this, basically. So this is where we update our counter. Every time we see a 0, we set it to, we decrement it. And every time we see 1, in this case else, is we increment it. And if this map contains the new count we found here, then we check the difference between the index of this position and index we save here. So index of this position is 0, 1, 2, 3, minus index of 1 is 1. So the difference is 2. So we return 2 for this one. And this will give me 2. And I will check and compare with the global maximum that I stored in the max number here. So that will give me my new max. So math.max.global maximum minus new number I find, that will give me, the new max. And I finally return this max. So let's see why we put 0 and -1 in this case. That's another tricky part here. So let's imagine this array, 0 and 1. And we will implement the same logic here. For example, if I put the counter is, I put -1, 0, and 1. Let's put this here. Sorry, I'll create another one. Duplicate. Okay. Oops. So, for 0, I put -1, okay? And for 1, I put 0, and none of them are in the array here. For 1, I put 0. And every time I see 0, I need to check if it's in the map, okay? So I put this 0 in the beginning as -1, and so put this here as counter 0 and -1. Then I can say this is the difference now. It's 1 and there's 0 here. It starts from -1. We will start this array from -1. And that's the index number 0. So I put 0, sorry, that's index number -1. We start the array from index number -1, and the value will be 0. So this way, every time we see a 0, that means, oops, sorry. Sorry about this. So anyway, so I put 0 here as the key, and every time I see a 0, I say 1 minus 1 is 2. 1 minus 1 is 2. So that would give me the length of this 2 array. This is the logic here. If I don't start it from -1, I need to say 0 plus 1. So in this case, length is 1, for example. 1 plus 1, 2 is the maximum length here. Because we start from -1, and I have another 0 here. Sorry, 0. 0 and 0. Index number is -1. 1 minus -1 is 2. In this case, it's the same. I come across 1, I come across 0, 1, and 0. But in this case, if I didn't put 0 here as the initial index and my index number 1, initial counter value, index number 1, that will give me the wrong result. So that will give me only 2. But in this case, we have 4. If it starts from 0, and to compare with 0, we put 0 here. And that's the, we start the array from -1. That's the idea. That's kind of, you can think about it the same as how we do with linked lists. We create linked lists starting from -1. So that's the idea. I hope this makes sense. Okay, so this is our algorithm. And let's see this in the code again. Created our hash map, put the first value here, created our counter maximum number, incremented counter every time we see a 0, and decremented every time we see a 0, and incremented every time we see a 1. Check if map contains the count. If not, put the new index into the count key in value pair. Max is maximum of the global maximum we store, and I minus the index number we get out of the hash map. So that will give us the new maximum number, and we return the max here. Let's submit. Okay, this one works too. So this is pretty much it for this question. I hope I made it clear. I tried this as much as I can. I hope it was helpful, and I have more videos coming up. So if you subscribe to my channel, we can meet again in the near future. Thanks for watching. Goodbye.